In today's fast-paced world of web development, every millisecond counts. If you're building dynamic, responsive user interfaces with React, you know that performance is key. That's why understanding how to minimize unnecessary component re-renders is crucial. It's not just about making your application faster, it's about providing a seamless user experience that keeps your audience engaged. By the end of this tutorial, you'll unlock the secrets of two powerful React hooks, useCallback and useMemo. These hooks are your tools for optimizing performance, ensuring that your application runs smoothly even as it scales and grows in complexity. Imagine being able to handle extensive data sets or complex user interactions without your app breaking a sweat. The knowledge you gain today will empower you to write more efficient and performant React applications, making you a more effective developer. Let's face it, no one likes an app that's slow or unresponsive. With the insights you'll gain from this video, you'll be equipped to tackle performance bottlenecks head-on, enhancing both the functionality and user experience of your applications. So, if you're ready to elevate your React skills, make sure to subscribe to our channel. We're committed to providing you with high-quality tutorials that keep you at the forefront of web development. Stay updated with the latest techniques and trends, and ensure that your skills remain sharp and relevant in an ever-evolving tech landscape. Now, let's dive into the problem at hand. React's re-rendering model, while efficient, can sometimes lead to performance issues as applications grow in complexity. But don't worry, we're here to guide you through the solution. Let's get started on mastering useCallback and useMemo. In the world of React, understanding how to manage component rendering efficiently is crucial for building performant applications. Let's dive deep into the concepts of useCallback and useMemo, two hooks that play a pivotal role in minimizing unnecessary re-renders. Imagine you're organizing a large event. You have a list of tasks that need to be revisited only when certain details change. If you recheck every task every time, you'll waste time. Instead, by noting which tasks depend on specific details, you check only the ones that need attention when those details change. This is akin to how useCallback and useMemo work in React. First, let's explore the React rendering process. React components re-render when their state or props change, using a virtual DOM to efficiently map these changes to the actual DOM. This virtual DOM acts like a blueprint, allowing React to identify what's changed and update only those parts. However, as applications grow, managing these updates becomes complex, leading to potential performance bottlenecks. Enter useCallback. This hook is like a reliable assistant who remembers your instructions, preventing the need to repeat them every time. It memoizes callback functions, ensuring they're not recreated on every render unless their dependencies change. For example, imagine you have a button within a component that triggers an alert. Without useCallback, each render might recreate the alert function, causing unnecessary work. By using useCallback, you ensure the alert function is stable, only altering when its dependencies do. Now, consider useMemo. It's like a sophisticated calculator that remembers results of expensive computations. When you have a calculation that doesn't change often, redoing it every time is inefficient. useMemo caches these results, recalculating only when the inputs change. For instance, calculating the factorial of a number can be resource-intensive. By wrapping this calculation in useMemo, you avoid recalculations unless the number changes. Both hooks share a common goal: performance optimization. They ensure components re-render only when necessary, reducing computational overhead. This is particularly beneficial in data-heavy applications or when dealing with stable callback references that, if recreated, could trigger unwanted re-renders of child components. In real-world scenarios, using useCallback and useMemo results in improved user experiences with faster load times and smoother interactions. Applications become more scalable, efficiently handling larger data sets and complex interactions without sacrificing performance. However, it's important to strike a balance. Overusing these hooks can lead to complexity and even degrade performance due to the overhead of maintaining memoized functions and values. It's crucial to evaluate when memoization is genuinely beneficial. In conclusion, useCallback and useMemo are powerful tools for controlling React component renders. By understanding their mechanics and applying them judiciously, developers can craft responsive, efficient, and scalable applications. As React evolves, these hooks will remain integral in addressing performance challenges, making them essential knowledge for any React developer aiming to build cutting-edge web applications. In this primary code example, we explore how the useCallback hook can help prevent unnecessary re-renders of child components by maintaining stable references to callback functions. This example demonstrates a component that renders a button, and the click handler for this button is memoized using useCallback. This example illustrates the use of the useMemo hook to cache the result of an expensive computation, in this case, a factorial calculation. By memoizing the calculated factorial, we ensure that this computation only occurs when its dependencies change, thus optimizing performance. Here, we present the configuration file necessary for setting up our React application environment. This file includes essential dependencies such as React and React DOM. For brevity, only the most crucial parts of the configuration are shown. In this demonstration, we are exploring a React application where we aim to minimize component re-renders using useCallback and useMemo. To begin, we navigate to the application, which is running on a specific URL. Once the page loads, we interact with various elements. Firstly, there's a button labeled Yes that we click, simulating a user's response. The application processes this input, and we observe any changes in the interface. Next, we turn our attention to a button labeled Increment Count. Clicking this button triggers an update in the application's state, specifically incrementing a count. We give the application time to process this update and reflect the changes on the screen. We click the Increment Count button once more to confirm that the component doesn't re-render unnecessarily, thanks to the useCallback hook ensuring stable callback references. Following this, we interact with another button labeled Increment from List. This action is designed to modify a list-based value, again observing that only relevant components re-render, demonstrating the efficiency brought by useMemo in caching computations. We then proceed to click a button labeled Increment Number. This further changes a numerical value in the application, and we ensure that the factorial calculation, which could be an expensive operation, doesn't run unnecessarily, thanks to useMemo. As a final step, we scroll down to the bottom of the page. This simulates a user exploring more content, and we take note of the smoothness of the application, a testament to the optimized rendering logic. Throughout this interaction, the user experience remains seamless, highlighting the effective use of useCallback and useMemo in minimizing unnecessary component re-renders and enhancing the overall performance of the React application. So there you have it, a deep dive into minimizing component re-renders using React's useCallback and useMemo hooks. By integrating these strategies into your development workflow, you're not just writing code, you're crafting efficient, high-performance applications that scale seamlessly. Think about the time and resources you'll save by reducing unnecessary computations and providing a smoother user experience. Now, imagine applying these techniques to your next project and the tangible impact it will have on your productivity and the satisfaction of your users. To continue honing your skills and staying ahead in the fast-paced world of React development, hit that subscribe button. You'll gain access to more practical, real-world examples that accelerate your learning and keep you at the forefront of web development innovation.